Bismillahirrahmanirrahim. This video is about mechanism of benzidine rearrangement. The benzidine rearrangement is claimed to be an example of the quite rare 5-5 sigmatropic migration, which is a 10-electron homologation of very common 3-3 sigmatropic rearrangement. And we can see the examples of such rearrangement like 3-3, the Cope and the Claisen rearrangements. You can see here 5-5 sigmatropic rearrangement for the rearrangement of the benzidine. This is the molecule of the benzidine. This is N having lone electron pair, and this is another N having lone electron pair. So in the acidic conditions, they accept the hydrogen ions to give this intermediate, and you can see here is the concerted reaction and the migration of the electrons. First of all, after protonation on this N and on this N, this bond break here, this migrate here, and this pi bond at the carbon number 5 is to be attached here by the deficiency which occurred to be due to the migration of this pi bond here and then here. So the covalent bond is to be formed between carbon number 5 of this ring and the carbon number 5 of this ring. You can see here in this intermediate. Now, after loss of the 2 hydrogen ion, we shall get this final compound. So this is the benzidine and concerted 4-center type of migration of 10 electrons take place, and we shall get this molecule from the benzidine. We can also see here, this is the benzidine. After accepting 2 proton, the protonation of the nitrogen atom occurred, and you can see here. So this bond would break here, and this bond would come here, and this pi bond is here, will act as the nucleophile, because after the breakage of this bond, this pi bond would shift here, and this pi bond would shift here. So the deficiency of the electron would occur at this position. So this pi electron would act as a nucleophile, and this carbon atom of this ring and this carbon atom of this ring would be connected in this form. You can see here. So this is an intermediate, and the carbon atoms here and here, they have been connected to give this intermediate. So we got the covalent bond here. So after the loss of the 2 proton, we'll get this neutral molecule. So the benzidine would end at this stable molecule through the rearrangement like this. So this rearrangement is totally intramolecular rearrangement because it is a concerted N-N bond breakage and C-C bond formation involving 5 atoms of each ring and 10 electrons as a whole in the system. In such situations, it is not possible to get crossover products as seen in slide number 4. The mechanism is passing through transition state and not through an intermediate. Therefore, no crossover product or mixture would be formed. You can see here the experiment for crossover experiment. And this is the benzidine. This is the substituted benzidine. Now you will get, after protonation in acidic medium, this molecule from this only, and this molecule from this starting material or reactant here. You would not get this crossover product. So no crossover product would be formed if we mix simple benzidine and the substituted benzidine. So we conclude that the rearrangement is intramolecular, and this rearrangement is not intermolecular rearrangement. So with the help of the crossover experiment, we conclude the benzidine rearrangement is totally intramolecular rearrangement. So it was all about this video. Thank you very much.